Hi, Mr. Pepperell here, and in this video we're going to look back over some of the stuff we've covered in the P2 topic, current electricity, and see how we can answer some exam style questions on the topic.
So in this section we looked at electrical charge, we looked at circuits, we looked at resistance and current and potential difference, and we also found out about the differences between parallel and series circuits, right? So for our first question, let's just have a look here. Our first question, we're going to have a little quick practice of actually drawing some circuit diagrams with the correct symbols. So my question says, draw a circuit diagram to show a variable resistor, two cells in series, and a bulb whose brightness can be adjusted with the variable resistor. So pause this, have a little go at drawing it yourself now. And welcome back. Hopefully you've unpaused it, you've drawn your circuit. Let's have a little look what it should look like. So here's the circuit I would have drawn there. Okay, I've got my two cells in series, so there's two cells, one after the other there. Okay, I've then got my circuit connected up to a bulb, and I've got a resistor here. But is that a variable resistor? No, not at the moment. I need to add one thing to it, so you should have drawn a arrow going across yours like that to indicate it's a variable resistor which can be used to adjust the brightness of the bulb. Okay, so there we go, we've got two cells in series, which obviously makes a battery, a bulb and a variable resistor. Okay, for this next question we're going to have a little think about the role that some different components play in a circuit. So have a look at the components that I've got written down here. We've got a diode, filament light bulb, a resistor and a thermistor, and I've got the sort of definition describing what those components do in a circuit there. So pause this, have a little look at it, and then come back and we'll see whether you can connect up the dots here. Okay, so hopefully you've paused this, you've had a little look at it now. So let's think about it. Firstly, a diode. Well, a diode is something that only lets current flow one way through a circuit. So for a diode, we can say that its resistance depends on which way round it's connected in the circuit. So you should have connected up diode with this definition here. Okay, the next one, a filament light bulb. Well, we know that a filament light bulb has got variable resistance in it. If you increase the potential difference and keep increasing it, it's going to increase the current that flows, and as that current increases, the filament light bulb is going to get hotter, okay, and that's going to increase the resistance. So for a filament light bulb, we should have said its resistance increases if the current through it increases. The increased current causes the particles to vibrate more because they're getting hotter because there's more things bumping into them, basically. Okay. The next one then is just a standard resistor. So we're saying for a resistor, the current through it is proportional to the potential difference across it. Okay, so we should have linked up that one there. Of course, we've only got one left to link now, but if we have a little look for a thermistor a minute, we can see that its resistance decreases if its temperature is increased. Okay, so that should have been your last link up for that one there. Okay, our next question is going to be looking at the rules for current and potential difference and resistance in a circuit, and how we can actually calculate some of those values. So if we have a little look at our question here, okay, a circuit has a 3-volt power supply connected in series with a 100 ohm resistor and a 200 ohm resistor. A voltmeter is measuring the potential difference across the 100 ohm resistor. So part A of the question is asking us basically just draw the circuit as described there. So pause this now, have a little go at drawing it, and we'll see how you get on. Right. Welcome back. Hopefully you've drawn your circuit and it looks a little bit like this. So it's asked us a 3-volt power supply. So I've drawn my power supply there and I've noted next to it that it's 3 volt. It's connected in series, so I've got a series circuit here with components following one after another. I've got a 100 ohm resistor and a 200 ohm resistor, and my voltmeter is measuring the potential difference across the 100 ohm resistor. Remember, voltmeters have legs, so they stand either side of it. And if we were measuring the current, it would have gone through it, and ammeters have arms. So that's what you should have drawn for that circuit. So we've got the same circuit here, exactly the same for part B of the question. This, spelling mistake, but it should be calculate the total resistance through the two resistors. Okay, now the rule for resistors in a series circuit is that the total resistance of the circuit is the sum of the individual resistances of the components. Okay, so all we've got to do here is basically add them up. So I've got a 100 ohm resistor, 200 ohm resistor. I'm going to add them both together, so the total resistance of the circuit is 300 ohms. So for this next question, I'm going to add an ammeter into our circuit. Okay, so I've added an ammeter in for obviously measuring the current for it, and the question is asking me what is the current through the ammeter. Well, to work out current, we need to use our equation of V equals I multiplied by R, and I've put it into the triangle here, so we can just cover up the bit we need to do. So in this case, we're trying to calculate current. Okay, so what I'm going to have to do is the voltage or potential difference divided by the resistance. So my voltage in this case is 3 volts. I've worked out my total resistance in the circuit is 300 ohms, those two added together. So all I'm going to have to do to work out my current is 3 volts divided by 300 ohms is giving me a current of 0.01 amps through that ammeter. So the next part of the question is saying to me, what is the voltmeter reading? What is the reading of this voltmeter here across the 100 ohm resistor? Well, again, we're going to need to use our equation triangle. Okay, this time we are looking for the voltage, so cover up the bit you don't need. Okay, and we're going to have to do I multiplied by R. So give it a little pause, work out what you think that voltage is going to be, and then come back. Hopefully you've been away and worked that out by now. So let's have a little look. What have I done to work this out? Well, quite simple really. All I've done is taken the current, okay, that we worked out in the last question, which was 0.01 amps, multiplied it by the resistance of the resistor that the voltmeter is across. So I've got 0.01 amps multiplied by 100 ohms tells me the voltage across, remember voltage is always across a component, the voltage across the 100 ohm resistor is 1 volt. Okay, this is the final part of our question now, and what they're finally asking us to do is work out the potential difference across this resistor. We've got no voltmeter there, but we can apply our rules to work out what that resistance is going to be. Okay, we've already worked out that the voltage across this resistor, over here on this voltmeter, was reading 1 volts, and we know that the rule for potential difference in series circuit is that the potential difference across the power supply is shared between the resistor. So we know that if this resistor here is reading 1 volt, well, what must this one here be reading? Okay, it's a fairly simple sum. You don't hardly even need to work this out. But if the total potential difference across the power supply is 3 volts, and this one's reading 1 volt, all I do is the 3 volts minus the 1 volt, which tells me that this resistor, the 200 ohm resistor, is going to be reading 2 volts.
So that is how we would use the content that we covered in P2 Unit 4 Current Electricity. We use that content to answer some exam style questions on it. Any problems at all with that, don't hesitate to tweet me at Mr_Pepperell on Twitter, and I'll get back to you ASAP. Thanks for stopping by.